Well, hello everyone, and welcome back to Adrian's Digital Basement. On today's video, we're revisiting the Commodore 1551 floppy drive, which you might have last seen on Super Mini Mail Call episode 101. When you last saw this disk drive, it was absolutely smashed, that is the plastic case, but also it wasn't working when plugged into one of the TED or Commodore 16 or Plus4 type machines with this cartridge interface. So in this video, I want to troubleshoot this drive and try to figure out why exactly it's not responding to commands in BASIC when it's plugged into the computer. So without further ado, let's get right to it. Now, it goes without saying that the smashed case for the 1551 has been replaced with the case from a 1541. The color doesn't match, but otherwise it's a good fit. In addition, the 1551, when I received it from Mike, was a European version, so a 220 volt transformer. So this is running with a transformer from the North American 1541. That means this is now a 120 volt floppy drive. When the original drive was damaged pretty badly, part of the badge got mangled a little bit, but I tried to straighten that out a little bit, and I think it doesn't look too bad overall. Clearly, the plastic color is wrong, but if it really bothered me, I could just take this apart and repaint the case. On the top of all these Commodore disk drives, for some reason, there's a removable Commodore logo, and I did save that from the original case, and I transferred that over to the 1541. And clearly one other difference is, since this has this permanently attached cartridge or paddle to the drive, there is no opening in the 1541 for this cable, so I just used the Dremel to cut a little hole, and it's actually not too bad. It's not perfect or anything, but it's not going to pull out. And now there are two holes for the original IEC jacks. Maybe I should put some tape over those, but for now, that's fine. I also transferred the original 1551 label over from the case that was smashed, because why not? I did put a sticker to remind me that this is a 120 volt drive and do not feed 240 volts via step-up transformer into the IEC jack, otherwise that would definitely blow up the transformer and probably damage the board as well. Using the 1541 transformer and case was very straightforward. No modifications were necessary. All the parts are kind of Lego pieces. You can just mix and match to make it work. And like I said, the only modification was the hole for the cable. Now, when I first tested this drive in the Super Mini Mail Call episode, and we'll do the testing over again, what was happening was when I turned on the power, we got the green power LED, the drive spun and stopped, which is a good sign because that behavior is coming from the CPU that's inside the disk drive. With these types of drives, there's actually a 6502-like CPU in there. I think this uses a 6510 variant, something like what's in the 64. If that CPU were not running code, for instance, the ROMs were bad or the RAM or some other issue, then I think the drive would just spin all the time and it would never stop spinning. Now on the original 1541 drive, a real easy way to diagnose that is when you first turn on, the spindle will run. That's the motor inside. Also, the LED comes on for a second and then shuts off. With this drive, on the other hand, the code is different and the LED never comes on. And I've confirmed that by asking someone who has a working one of these drives. That LED always stays off even if you power cycle the drive. So I'm going to power it back on and no LED. That's just one of the differences on the 1551 versus the 1541. And these subtle differences are very helpful in trying to diagnose where the problem might lie exactly. Okay, so let's do a little bit of troubleshooting. I have my Commodore 16 out on the bench. So with both the computer and the disk drive turned off, I'm going to plug this paddle or cartridge into the back of the machine. And first I'll power on the floppy drive. So power LED, no drive activity, but that's expected. And I turn on the computer. And as soon as I turned it on, the motor does run on the disk drive just for a few seconds and then it shuts off again. But here's where we're starting to run into issues. So if we type the command directory, what it should do is try to do a directory of the floppy disk that's inserted in the drive, which there isn't one, but that's fine. We hit enter. Wait a second. Okay, I'm sorry, but I don't understand what's going on. It's trying to read the disk. And I kid you not that I was just testing this before starting this video. I wanted to validate that after putting the disk drive into this case, that it definitely still wasn't working, and it was not working. Originally, when you typed directory, it would say device not found, and of course the drive itself wouldn't do anything. But now the red LED is blinking, which is the normal behavior when you don't have a disk in there. So I'm going to do directory again. And now it doesn't do anything, it just says ready, but I think because the drive's in error state right now. So I'm going to power the computer off and on, and that should reset the drive, so that should stop the flashing LED. And it does. And we're going to type directory again. It's trying to read a disk. I don't understand. I didn't do anything at all here to try to fix this. And worse is you might be thinking, okay, maybe there's a problem with my cartridge slot on the computer. Well, before I was doing this video, I also inserted my diagnostic cartridge, and there's the computer running the diagnostic, and I let this cycle for a while, and obviously the computer was fine. It was cycling through the diagnostics. The cartridge slot is working. I'm plugging the paddle back in the computer, turning it on, it resets the drive. Let's see if the drive is... Oh. Okay, interesting. Now the drive's not spinning, and the computer is just sitting there. I'm going to turn it off, and I'm going to power cycle everything. Okay, drive is reset. Power on the computer. Now we type DI Shift R. Oh, and look, now it's not working again. Although it's different, because before it would immediately just say device not ready or device not found, something like that. Same error you would get on the Commodore 64 if you try to access device 8, which is normally the disk drive, when the disk drive is not plugged in or turned off. So this has me thinking, could this be an issue with the cartridge slot, not making good contact? I'm going to put some Deoxit on here just to make sure. I think I did this already in the mail call episode. That was a few months ago, so I don't remember exactly. But let's just jiggle this around. Turn the drive off, back on, turn the computer on, DI, Shift R. Now it's trying to read. Unfreaking believable. Okay, I don't know what just happened on the computer. The screen went blank. That doesn't make sense. The drive has an error, which of course it should. There's no disk in there. All right, what I'm going to do is I'm going to use one of my cleaning floppies just to see if I can clean the heads. I don't think I even looked at the heads or tried to clean them. And unfortunately, I've screwed the drive all back together again, so I can't easily access the heads. And interesting, as soon as you stick the disk in there, the spindle turns. And I think that's because it's interrupting the write protect switch. So I'm going to close this. One of the issues is this is a Neutronix mechanism, and these are notoriously unreliable. So I'm going to try to access the drive, and it's not accessing. I'm going to power cycle the computer. It's making the drive spin at least. Yeah, we're still having issues. It's funny, it doesn't give me an error. It's like freezes the computer. I wonder what is happening here. I'm going to jiggle that, turn this back on. Okay, it's trying to read. It just said ready. I completely believe that that's normal if the disk is not in the drive. I'm just going to power cycle the computer a few times, which should make the disk spin a little bit. Okay, it's still working. Well, I don't know if it's actually going to read anything, but at least it's trying to spin the drive. It's actually trying to read something. All right, I have a couple discs, which I'm going to try to read, and one of these is David Murray's Attack of the Petsky Robots, and this is the Commodore 16/+4 version, and I've never actually used this disc that he gave me, and that's because I haven't ever had a 1551 that worked. You probably could have used a 1541 with this machine. It does have an IEC port also, but it would be very slow. So we'll try that in a second. But first I'm going to try this drive alignment for the 1541. This is a disk I made, and it's not going to work on this. In other words, I can't run the software that's on here because it's Commodore 64 software. But it should be able to at least read the disk. So let's do DIR. Let's see if it can even... Okay. No, I heard it trying to seek, and it wasn't actually working. I'm going to do load star comma 8. Well, it just headbanged. Okay, file not found error. So it was trying to read there. It means at least the computer now is communicating with the CPU that's inside the disk drive. So the drive has a flashing LED that tells us this is an error of some kind. So I typed in the little basic program, which hopefully I did correctly, that should read the error channel out of the disk drive. And we type run, and the error we got was drive not ready. Now this is actually coming from the CPU inside the disk drive. The disk operating system is contained on the ROM in the drive, and that is what's generating this error. And theoretically, if we type directory and we enter, it's going to try to read the disk. It's head banging, and then just says ready. But if we run this program again, now the error is different. It's 21 read error. So the funny thing is here is that the drive now appears to be communicating to the computer, which frankly it wasn't doing before at all. No matter what I did in that Super Mini Mail Call episode and earlier today, it always just said device not ready, and it never actually had the disk drive do anything. No matter what you did on the computer, it never was able to communicate to the floppy drive. But now we're left with an issue where it's not able to read this disk at all. Now what we can do just for fun is try a different disk, this one that David gave me. We type directory, and it just didn't do anything. We have a flashing LED. We type run, and now it says drive not ready. Let's try directory again. There we go, it's doing a headbang, which I'm assuming now we're gonna get a read error when I type run. Yep, back to read error, same exact error we had before. So with the original issue that this was having where the computer could never communicate to the disk drive, what I thought was wrong was something inside this cartridge. Inside the cartridge is actually a PLA chip, and it's very similar to the PLA that's in the 64, just has different equations on it. The other chip inside here is a 40-pin DIP that looks like a 6526, but I think that's a different part number. It's an MOS designed CIA, or complex interface adapter. It gives you a bunch of I/O ports, a couple of status lines, and 8 data bit lines that go from the cartridge, or the computer that is, into the floppy drive. So BASIC in the computer must program that CIA chip in here, and then that talks to the disk drive, and it gives you that much faster interface than a serial I/O, which is what IEC is. Well, it was my assumption that that PLA chip that was inside the paddle had failed, which meant the computer was unable to communicate with that CIA chip, since the PLA that's inside the paddle generates the chip select line for that IC. So my hunch was that we'd have to look at the chip select line on the PLA chip and make sure that it was good, and if it wasn't, then we know that that chip was faulty or some issue around it, and maybe swap that out. But now we turn that on, we turn on the computer, let's see if it's still working, and it's not. There we go, I just jiggled the cartridge around, and now it is trying to read from the disk drive again. Let me just jiggle the cartridge around and see if I power the computer on. I just want to see how reliable or unreliable that is. Okay, yep, it's still working. So it seems like maybe that we just had a bad connection the whole time in the back of the computer. And that was the entire issue. Yep, trying to read still. Okay. Well, what this tells us for sure now is that there's no problem with the PLA or that CIA chip that's inside the paddle. It was probably just a bad connection the whole time. And the issue is something in the disk drive now. We know we're communicating with the operating system that's in the disk drive because we're able to get those error response codes back from it. So we have some issue either with the floppy drive itself or the analog electronics that are on the controller on the floppy drive. If you're familiar with Commodore floppy drives, like the 1541 or even this one, you'll know that the mechanism that's in this drive is of the Neutronics variety, and they are notorious for having bad read-write heads. I personally haven't run into one with a bad read-write head, but I've seen plenty of other people do that. So that's going to be our first avenue of diagnosis to try to see why this thing is not able to read anything. And let's crack open the floppy drive and take a look at those read-write heads. And I suppose one of the first things I need to check, did I even plug the cable in correctly? And that's because I did take it off when I was swapping the drive over into the new case. Oh, okay, well I can tell here that I did not have it plugged in correctly. The odd thing is, it has 1 there and there's a 1 on the board, so you'd think that would be the right way to plug this in, but it's not. Check out the gap where there's not a pin. And we can clearly see that the gap is close to the 5, and on the drive it's next to the 1. So I had this backwards. So that tells us right there that it's impossible that this drive was gonna read anything with it hooked up incorrectly. And that was totally my doing. Look at these parts, by the way. We can tell that the main CPU is a 6510, but it's a T variant, and I can't remember what the difference is. But the other bespoke parts are these, I see, 6525. This is that CIA I was talking about, and there's one inside the cartridge as well. This is sort of like the 6526, but different. And I don't think they're compatible, at least not without creating some kind of big adapter. Then the other components on here are the main ROM. There's a static RAM, I think same 2K that's on the Commodore 1541. And then this 40-pin IC is like a, I don't know, I guess you could call it a ULA, uncommitted logic array. I think this combined a lot of the chips that used to be on the 1541 down into this small package. In addition, this small MOS IC is also a custom chip for the floppy drive. And I saw one of Mark's videos at the Retro channel where he worked on a 1551 disk drive and that chip had gone bad. Luckily, that chip also seems to be used on the Commodore 1571. I'm not sure about the 40-pin one, but that small one is. So he borrowed one from that drive that was working and was able to confirm that that was the bad IC. But again, these custom chips, I don't think there's any replicas for them. So if those go bad on your drive, you're kind of up a creek, or you're stealing those from another disk drive if it happens to be that those are on another disk drive. But without a doubt, this 6525 is unique, as far as I'm aware, to this disk drive, and same goes for what's in the paddle. Now, the PLA that's in here, there is a replacement for that if that is bad, and that's where I thought we were going with this video. Clearly, that's not the case. This large package is a hybrid, which has a bunch of electrical components in there. I think that's all the analog components that essentially make up the read-write differential amplifiers for the heads there. And if this goes bad, you're probably in trouble as well. Although, I think I definitely remember seeing this on some other Commodore disk drives. Maybe 1571s have these, and maybe some of the very late model 1541s. The Neutronix mechanism itself is going to be identical to the one that's in the 1541. I did write 1551 on this one just so I could keep them separated. But I figure if the heads were bad on this, I could just swap a Neutronix mechanism from a 1541 and it's definitely going to work. The connectors are all the same. All right, so I have this stuff all reconnected again. I'm going to power it all up. So let's pop in this 1541 alignment disk, and I'm going to type dir Shift E, and let's watch if the head moves. No. Oh, yes. It's moving, and I think it's working because I'm not getting the flashing light. Well, that didn't work though, because it just says ready. That's not working. Let's try it the other way. Yeah, file not found, and the LED is now flashing on the disk drive. So let's power cycle this again, and let's try it the old-fashioned way. It's odd because it gave up a lot quicker before. And now it's like trying to read stuff. So I put the cleaning disk in there. The heads look clean, but just for fun, I'm going to give this a manual clean. Just want to make sure that it's good and clean. Yeah, there was nothing coming off of that. So I was very hopeful that this would have worked because I had this on the wrong way. Let me just validate that it's on the right way now. Yes, it is. That is on correctly. I power cycled the computer and we'll type directory again. I mean, it's certainly trying to do things. It's not head banging though, which is odd. And clearly we got nothing. Normally you'd get a directory listing immediately. I'm just gonna try David Murray's floppy disk here as well. I'm sure this is not gonna work. Yeah, it's doing exactly the same thing. Okay. So anticipating that this might be a problem, I have a 1541 Neutronix mechanism. Let's take a reading of the resistance of the heads on this drive versus the 1551, and let's see if we can detect any differences. The multimeter is in resistance mode, and I have my very sharp probes, and let's poke around on the heads here. 26 ohms, and that's between the two pins where there's a gap between them. 14 ohms on the middle two pins. And between pins 1 and 3, 25 ohms. And between the two outside pins, 1 and 5, we're getting 23.79 ohms. So here is the 1541 drive. I don't know if this even works or not. This came out of a parts drive as well. And let's measure the resistance on these components. 25, that was the same. Pins 1 and 5, 22, it's slightly lower, but that seems pretty much the same. 11 on pins 1 and 2. Between 1 and 3, 25, 25 between 3 and 5. We got 11 between pins 2 and 5. I mean, it all seems pretty much identical, doesn't it? Yeah, we're getting 13 between pin 2 and 5 on this one, 26. I mean, it's close enough. I would expect if we saw like kilo ohms or mega ohms or something, that would be an issue, but we're not seeing any of that. I suppose for grins, let's connect up the 1541 mechanism. Let's see if this thing works any better. Just checking to make sure that the heads are clean. They look clean. So I'm going to pop the alignment disk in. Okay, so I'll do a load star. Okay, trying to load the directory. Okay, file not found. Now if I unplug the heads, I'm just going to leave them off. We'll power cycle the drive to reset it. Let's try doing a directory again. Okay, very quickly gives an error, and that's with the heads disconnected. So the controller is able to tell that the heads are connected or not. So obviously it's reading some kind of signal when the heads are connected. It's just not able to make sense of them. I did a quick Google search to see if those resistance readings we got on both mechanisms was correct. And this post on Reddit from 4 years ago says that all the readings need to be below 100 ohms. If one of them, usually the red one, has no connection to the rest, the head is bad and the drive is only good for spare parts. And yeah, it's not fixable, those types of problems with the heads. Actually, it's like a bonding issue inside the head itself, so basically turns to junk. Thanks for your reply. I just tested it and got resistance values between 13.9 and 27 on the 3 pins, but the red one isn't reading at all, so the head is bad. Okay, well, we were reading that red pin, because that is pin 5 over on the edge here, and that without a doubt on both mechanisms had a resistance value. So it seems like both of these mechanisms have good read-write heads. So I'm confident in saying that the read-write heads on both of these drives are fine. And unfortunately, I was hoping that my only issue was I had the connector on wrong, but it wasn't the problem either. We obviously have an issue on the board itself when it comes to the way the amplification works for the head signals that's keeping this from reading any discs. So this is a perfect opportunity for us to jump to some schematics, and I'm over here on Zimmers, which of course has collected a couple different types of schematics for the disk drive. There are 2 versions. One was a reverse engineered recreated schematic, which I've heard has a couple little errors, and then we also have older original Commodore scans. I think they are, because when we look at these look very much similar to all the other Commodore schematics. Yeah, in fact it says Commodore right on here. Flipping over to the floppy drive itself, this is the recreated schematics for the floppy drive controller, and there's a 6510, so the main CPU. We have the 6525, which is the CIA chip that's like a 6526, but not. On the schematics, we can see the ROM chip, we can see the SRAM, and then we have the custom IC. So U6 is the 40-pin IC that I said was like a ULA, and this is that little small IC, U7, a 251829-01, that Mark at the Retro Channel ran into being bad. Well, this seems to be like a miniature PLA chip where it's actually handling the ROM and the RAM enable and chip select lines and some IO lines. I don't think this is a problem on this drive because it's fully operational when it comes to the CPU. The problem on here is strictly in the read-write circuit itself. So I think we could ignore that chip as a culprit. And then U11, I think, is that black hybrid module that I talked about that has the read-write amplifiers inside. This has the connection to the read-write heads, and P3 is that connector, the one that I had connected backwards. Now we can infer by the fact that the drive acts different when the head is plugged in versus removed. So that tells us that this thing is working to some extent at least. Like this little power supply circuit that is powering it through pin 1 on VCC probably is okay, although it might be worth measuring to see exactly what voltage we're getting here. This hybrid IC also handles other functions. So 0, 1, 2, 3, these Y lines, these must be phase lines that go to the stepper motor for moving the head around. This is P4. I think that's probably okay because the head's moving back and forth and it's doing the head bang and whatever. So I think that signaling is probably working totally fine, which kind of tells me that this whole thing is powered up, because if it weren't powered up, I don't think we'd get any head movement either. When we think about it, there needs to be a way for the hybrid to be able to read the disks, read and write to the disk. So there needs to be a data input and a data output signal. And I'm kind of thinking it's probably this pin 19. We should probably scope that while the drive is trying to read. And it does go to that little miniature PLA kind of thing. But that doesn't really make sense actually, because I don't see any data lines coming out of this. It has IO 1 and 2 and they're not connected according to this. Clear, PLL, ROM and RAM enables, address lines, test, data sync, and oscillator. Okay, so a few things looking at this don't quite make sense. So I'm going to switch over to the official schematics. This makes a lot more sense. So read-write heads have the read and the write signals tied together, which is normal. It switches between them depending on what's actually happening. When you're writing, it also engages the erase head, so it erases first and then writes to the disk. But then when you're doing the read signals, it's just going to be pin 11 and pin 2 that are doing their thing. There's an inductor that is connected between L1 and L2. We need to check to make sure that's not broken, maybe in transport. There's a data pin, pin 19, that makes its way over to that little mini PLA. I'm not 100% sure what this signal does. Like, it's an output from here, so is that for writing? That might be for writing, maybe. But then there's these Q signals, Q and exclusive Q, which is inverted. And those make their way to these gates. And that goes down to the gate array. Sorry, I was calling it a ULA, but yeah, gate array is a better name for it. Well, clearly that's an output, so that makes its way into the hybrid IC. That is not for reading. But then there's this W pin, and I wonder if that is somehow for reading. Can't tell what the marking is on there, but we might need to poke around with that with the oscilloscope. And then the pin that says out, that has something to do with the indicator LED. It's got to, because there's motor on signal here from the main CPU, and it's sort of all connected to that. So that doesn't have anything to do with the data that's coming out of this hybrid IC. But without a doubt, 100%, when you're reading disks, it goes into the hybrid IC and some data stream comes out of this and it's read by some other part of the disk drive, without a doubt. So we need to poke around on this thing while the disk is clamped and inserted and spinning, and look for appropriate signals coming out of the hybrid IC. All right, visual inspection time. That is the little inductor I said I need to check to make sure it's in good shape, and looks totally fine. The hybrid IC itself looks fine. I don't see any cracks or anything that looks sketchy on there. Just gonna turn off the disk drive. What's this here? Here's something. Look at that. Looks like to me that that's a cut in the board. I don't think that could have happened from damage. That had to have been on purpose. I don't see any other way around it. Oh yeah, look, there's a cut there as well. I wonder what that's all about, but that's gotta be a factory mod. There were a couple bodge wires on the bottom of this, and that is clearly something that's happening on purpose. Otherwise, everything seems fine on the hybrid IC. That is pin 1 there, pin 31 over on the left. Looks like we have a jumper link that has a blob of solder on it, JP2. And then there's another jumper there, JP1, that's also bridged. I'm just looking around for anything else that seems out of the ordinary. So far, everything looks fine. This thing, even though the whole drive was traumatically damaged, this thing looks fine. Don't see any issues. This is probably the little power supply for the hybrid IC. And the schematics tell me that it's pin 1 that is the power supply input for the hybrid. That tells me that they cut that trace because that's probably just 5 volts, and that little extra power supply probably has a bodge wire underneath that supplies this with power. That'll be pretty easy for us to tell. So let's check what this rail is here. Yeah, that is 5 volts, the one that they cut. And actually, it is 4.96 volts on pin 1. There's that Zener, 3.6 volts. Maybe that little power supply was put on the board more for stability. I mean, as if this isn't clean enough already, but maybe they just wanted it even more clean. Yeah, there's the continuity, and it comes from the transistor Q2, which matches the schematic. So there must be a little bodge wire underneath there connecting that up. So not sure why they did this, but they did, and it seems fine. Okay, I have the oscilloscope up. Let's start poking around. I want to see where the data comes out of this hybrid IC. Okay, I'm on pin 3. The drive is off right now, so turning it on. It's a bit noisy, isn't it? Let's clip into a better spot. There we go. That's a better ground. Okay, turn on the computer. Nothing. DI Shift R. Okay, so pin 3 is the W pin. That's clearly not a read pin. Okay, we're on pin 9 now. That doesn't seem to do anything either. Okay, I am on what is the data pin, which even when the drive is not spinning, we got plenty of activity here. That is interesting. Now, if this is truly the read-write signal, as it's reading a correct signal, that randomness should stabilize. I'm gonna have to reset the computer first. Oh, that looked better. So DI Shift R. Yes, that is what I would expect to see for a data. If I unplug the read-write head, you'll see it will turn to junk. Yep. So I think that is strictly noise. And if I turn the computer off and on as the disk spins, looks correct. Yes, yes. Let's go back to DC coupling. That movement you saw was because it was on AC coupled. Okay, I'm blind typing a command to load $. Yeah, I mean, that looks good. That is completely what I would expect to see for a read signal. So that's pin 19, the data line. And that makes its way into this little mini gate array, the mini PLA I called it, pin 3. Let's check pin 3 on that IC. Okay, that's pin 3 on the IC. That's the same signal, so it's getting to it. I just wanted to make sure there wasn't like a crack in the board or something. No, that looks normal. So now my question is where does this signal go? How does this get over to the CPU? How is it able to read anything? because this has chip select line, ROM enable, RAM enable, address lines, and then we have a 16 megahertz oscillator input, I suppose, into that chip. We know that's fine. If that were bad, well, let's just check it anyways. But if that were bad, we wouldn't have a working CPU. Yep, there it is, 16 megahertz on pin 1, so that looks totally fine. But yeah, we wouldn't have a working disk drive if that clock were not working correctly. So the other signals that look like output signals, there's a sync and a clear and a PLL. Let's look at where sync goes. Pin 2, there is the sync pin, 6523, and the gate array. Let's look at that sync pin. All right, so that is the sync pin. Let's power cycle the thing. Oh, when the computer's off, it's kind of random. When the drive was spinning, it was doing nothing. DI Shift R. So we lose that. Oh. Huh. I don't know. Kind of comes and goes. Well, that doesn't really look like a data signal to me. Maybe like an index pulse thing. I don't know. The fact that it's still there while it's not spinning tells us that that's something else. All right. Other signals. Clear. Pin 11. Let's see where that goes. That goes to the gate array. Pin 23, it looks like. Okay, I'm going to power cycle the computer. Doesn't really do anything. Doing a directory command. It's not doing anything. So whatever that clear command is, nothing. So we looked at sync, we looked at clear. Now there's this PLL signal. Okay, this is the PLL signal. I'm going to power cycle the computer. Let's see if this gets some stability as soon as it starts spinning. Okay, interesting. Okay, so the drive is spinning, and that certainly looks more stable. Yeah, that's interesting. So that's something to do with timing of the disk, I think. I don't think that's not necessarily a data signal. I must be missing something simple that takes the data from this over to the drive itself. But what is it? Those are the stepper signals, so it's not those. It's obviously not these Q lines because those have gates that are driving, towards the hybrid IC, so it can't go backwards there. It's not this out signal because that, if we follow that trace, that makes its way right here to the drive motor. So that's pretty much when the drive motor is turned on by the CPU, then that signal goes into the hybrid IC. So it must just tell it the drive is actually spinning or something. This is the CPU. Byte latch, DS1, DS0, WPS must be write protect, ACT0 must be the activity light, motor on, stepper signals. It's so ridiculous because all of these signals combine into these two traces, and one of them makes their way down to this IC, the gate array. It doesn't even say what it is, what signal it is. So it's not DS1 and DS0, but it's something. We just don't know what. I'm quite sure that these step signals that come from the CPU are turned into these 4 phases, these Y0 through Y3, that makes its way to the hybrid IC, and then that makes its way to the stepper motor to move the heads around, and that's fine. Okay, I looked online, and it seems that they use the header command to format a disk. U9. Okay, so this said it should do a full format. And I want to see, before I hit enter, I want to see if we see anything on that write signal. Okay, down here it says U9, device number 9. So I just changed it to 8. Are you sure? Yes. The head banged. Oh. Okay. That is not me. It's doing that. Like that up and down. That's coming from the hybrid IC. So I guess that is a write signal. That's all that makes sense. Okay, well, I'm kind of stumped a little bit here because I don't know the way it should be working. I don't know what these signals all look like. I don't know where the data is making its way back to the CPU. I still don't know exactly where that's supposed to happen. And I'm feeling that there's a problem in either the hybrid IC or either of the two ULA or gate arrays that are on here. So I don't have another 1551 to compare to, but I think I should have a 1541C, or whatever the later version is, the small cost-reduced one. And I think I also have another 1541. It's the white version. It's full size, but it's white. And I think it might have a similar board to this. I'm going to go grab those and look at those and try to figure out what I can figure out from those. All right, great news. I went and grabbed a 1541 that looks like this. This is the kind of the later version. I think this thing is interesting that it has a track 0 sensor in it. I popped the screws off of it and take a look inside. Does that not look nearly identical? Yes, it does. Obviously, these are different boards, but they both have the hybrid IC. They both have the mini gate array. There it is on both. And then they both have the 40-pin gate array as well. I'm pretty sure these three parts are the same on both of these disk drives. Well, which is excellent for two reasons. This drive works, so we can compare the signals we're seeing on this with this one, try to figure out what's failed exactly. And if I'm able to figure out on this drive which is the failed part, then maybe we can temporarily borrow the part from this, so then I can figure out which part I need to procure. Okay, so I think we have a good idea of what signals we're seeing on the bad disk drive, so I'm going to move it out of the way. And I'll use an IEC cable to connect this up so we can still issue commands to this drive. I'm going to put in this disk, which is formatted already, into here. Now, when we do DI Shift R, device not present. Oh, give me a break. Is this drive not working now? The spindle spins when you power on the computer, when the drive resets. That all works as normal. Okay, I'm not sure what's actually going on here. I'm wondering if something with my Commodore 16 with the IEC port. I know I've run the IEC port on this and it works, but I would rather just use my Commodore 64 because I just know this works. And sure enough, there we go. We just read the disk. Okay, so that works. Cool. So I can just push F1 a bunch of times while we scope the signals on this drive. Okay, first signal is the right pin. And just like on the other one, pin 3, that doesn't do anything. Let's take a look at this data pin, pin 19. Okay, there's 19, looking good. That's exactly how the other one looked. When I do a command to read the disk, it should stabilize. Yes, it does. Okay, so that pin pretty much works exactly as we'd expect and looks identical to the other one. There it is in the idle state. Okay, well, let's focus on the data signal. We know that data signal looks good on the working disk drive. It looks just like it did on the other one. Let's take a look at that sync signal, because that's one of the other ones we were looking at. Pin 2 on that funky little PLA guy, or mini gate array. Okay, there it is. So I'll put the disk in. Looks similar. Read it. Well, doesn't that look different? That does look different. Let's get that. Okay, so it's kind of all over the place. I don't recall seeing a double pulse like this. Incidentally, the clock signal on the 1541 is also 16 megahertz, so that is the same. Okay, this is the PLL signal, pin 12, and we were looking at this. It's kind of noisy, isn't it? Let's read something. Oh no, that looks the same. That is definitely how it was on the other drive. I remember it was random, and then it kind of got organized and repetitive as soon as I started reading the disk. And a little bit of jitter, which comes from the fact that disk speed is not perfectly consistent. Okay, so that seems correct. Okay, how about this CLR signal on pin 11? Huh. I kind of remember on the other drive, this line did nothing. Did nothing at all. Okay, so I want to take a look at schematics for the 1541B, which I think is what this one's technically called, the one we're looking at. Because maybe we can glean more information with the way this all works based on this schematic. Okay, so there's that data signal on the 1541, the one we were looking at. That makes its way over there, and it only goes there. All right, to help understand things a little bit better, I went to the service manual for the original 1541. I don't think we have service manual for these later versions, but I assume functionally it's similar. It's just the read circuit has a bunch of discrete components, and now it's all in the hybrid IC. During read operation, data from the read amplifier is applied to the CLR input of counter UF4. The outputs C and D are shaped by the NOR gates, and UE5 outputs the serial data on pin 1. It is then converted to parallel by UD2, and the output of UD2 is latched by UC3. Serial buses are then counted by UE4, 8 bits, blah, 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 blah. So it's using that CLR. That's completely unreadable. Okay. Well, it's using that CLR pin though. Which is right there on the little mini gate array, pin 11. Let's take a look at that pin on this working drive, and let's go back to the other one because I think that was different on these two drives. Okay, so right now as the drive is sitting idle, I'm on pin 11, the CLR line, and if I read the disk, it's doing stuff. And I assume it's actually reading the disk properly. Yes, I think it is. Okay. Okay, the C16 is out. Let's power this on. DI, Shift R. Let's get on that pin. Okay, it's random. I mean, does that look same? That looks the same to me. Okay. I think it just headbanged. That's funny. Yeah, that definitely looks very, very similar. If I unplug the read-write head entirely and we power cycle it, what's going to happen if I try to do a DIR now, it doesn't look the same, but that's because the heads are disconnected. Yeah, I mean, that certainly looks like it's exactly like the other drive. So data is applied to the CLR input of counter UF4. The outputs C and D. Let's try to look at the 1541 schematics. So the CLR output comes out of the gate array, and according to the other thing, the outputs on here are C and D. C and D. This could all be happening internally. Shaped by NOR gates, and UE5 outputs the serial data on pin 1 and is converted to parallel by UD2. Well, this chip, the big gate array, has the parallel data on it already. It's pins 2 through 9. Let's look at those pins and see what kind of activity is happening on them while I try to read a disk. Okay, I'm on pin 2. If I power cycle the computer, let's try looking at something. I mean, I don't know. It's obviously doing something here. So that's pin 2. Kind of my assumption is the reason why we're seeing a bunch of random garbage right now is because it's decoding the data that's being read from the heads, but you know it's just static because the disk isn't spinning. And the fact is, as soon as the drive is spinning, it starts to look correct, which is that. Okay, that's pin 4. 5. I'm just looking for any that aren't working. That looks fine. 5. 6. It's good. 7. Looks fine. 8. Looks good. And pin 9. They all look fine. Like that output, when I power cycle the computer, all looks basically the same. Because I was thinking if the gate array maybe has a bad output going back to the 65, well, it's going back to the 6523 on the other disk drive, not to 22 like it is on the 1541. But it says the data is converted to parallel data and the output of UD2, which is that parallel data, is latched by UC3. On the 1541, that's the 6522. The serial bits are counted by UE4, which is a chip up here with the CLR pin. And when 8 bits have been counted, UF3 pin 12 goes low, UC3 pin 10 goes high, and UF3 pin 8 goes low, and a byte is ready to be read by the processor. So like latch it in. Oh, look, there's a byte line. I wouldn't be surprised at that or at the sync signal as well. Okay, so I am on pin 17, which is a sync signal. Interesting how it just sort of went to nothing as soon as I tried to power it up. And I bet you if I try to read anything, we'll just see nothing. Oh, no, okay. Stuff is happening. Like it's trying to read the disk. It's not successfully reading, but that sync line is pulsing. Okay, it's pulsing right now as well, even though the drive's not spinning. So now with the computer off, that sync line is just random junk. Okay, let's do DI Shift R again. Huh. Interesting. Well, let's take a look at this byte signal as well. That's 42. That does not make sense. And we're looking at the 1551, not the 1541. But why is there 2 megahertz on that byte signal? Which according to the schematics, the recreated schematics of 1541, that's just looped around to this ATN in pin 25. Is that even used on the Commodore 1541, I wonder? Pin 25. Yeah, there it is. 25. ATN in. Okay, hold on a second. Hold your horses. This gate array, UC4, I'm looking at it right now on the disk drive. It says it's got 42 pins. It doesn't. Or does it? No, it doesn't. That's a 40-pin dip, without a doubt. But it has extra space there for pins 21, 22, and that would make pin 42 that one. And I was measuring down here, so I was measuring the wrong pin the whole time. I'm going to check again up there. Actually, I could just tell because that should be connected to pin 40, I think, of this IC right here. Okay, yeah, that's the byte signal. Pin 42 is pin 40. Okay, so I was looking at the wrong pin the whole time. Let's do that scoping again on the correct pin this time. I don't know what I was thinking. Why I was looking down there, I don't know, I saw 42. I think I thought it was 24. I don't even know what I was thinking. I don't know. All right, well, there is the byte signal. When I push the read command, you can see that there's more stuff happening. Watch, I'll do it there. So I think that's what it's supposed to look like. We need to look at the 1551 now and see if that looks the same. Okay, so that's the byte signal. Okay, let's do DI Shift R. I don't know. I mean, at least it's not missing. Let me unplug the read-write head. Kind of is more random now, isn't it? So when you start to read, you get nothing like this, and then it comes back. Doesn't really look like the other drive though, does it? Like the drive is spinning right now, and it looks like that, but if I take the disk out, well, the disk stops spinning, it looks the same. Okay, well, I am still totally stuck. I found no smoking gun that looks completely wrong, but again, I don't really fully understand how this circuit works. So I feel like it's either the small gate array, the big gate array, or the hybrid IC. I still think it's one of those three causing this issue. The thing is, the 6523, the CIA that's on the 1551 disk drive, it needs to know, hey, latch the data that I'm presenting you from the gate array, and that's that byte signal, but it doesn't seem to be that byte signal. So maybe that sync signal is the one that is working, and that is pin 17, which I think we've looked at, and that looks correct. So I suppose our issue could also be the 6523.CIA. Maybe there's something wrong with this data lines, it's not able to latch the data properly from the gate array. I don't know. I'm not seeing any smoking guns. We looked at all the data lines that go between the gate array and the 6523. Those all look fine. We see that CLR signal going into the big gate array. That looks fine, it matches the other disk drive. So I think what I'm gonna do is I'm gonna just desolder both gate arrays from the 1551, and I'll probably do the same on one of my other disk drives that has the same two chips, and we can test them by swapping them around and seeing if that fixes the problem. I hate fixing things like this, but I'm kind of stuck. I don't know what else to try. Okay, so I had dinner, and I had some time to kind of think about what was going on here, but also I did socket both the large gate array and the small one. These are the original ones from the 1551. They're just back in there. I just wanted to make sure that I didn't inadvertently fix it by socketing those chips. I also had a thought about what exactly was wrong with the IEC ports on the Commodore 16, and I know exactly what's wrong. And it's not a physical problem, it's a problem with the kernel. All right, so I just turned on the disk drive, and we'll turn on the computer. And my assumption is we will have, hopefully, a non-working disk drive. Okay, it's trying to access the disk. And yeah, pretty sure it's not working. I'm glad that didn't actually fix the problem, I'm going to take a moment away from the disk drive and I'm just going to fix the problem with the IEC port on this computer. So way back, as in a few years ago, I modified this particular Commodore 16 because this thing didn't actually have a working CPU in it. So to get this thing working, I actually installed a Commodore 64 CPU, and I had to do that with an adapter. And that's because when Commodore made the CPU for this machine, it's very similar to the 6510. It's just that the extra pins on the CPU that are mapped to a port, I think at 0000, they're slightly different on the CPU that was in this machine. So to use a Commodore 64 CPU, you have to use an adapter, and then you have to modify the kernel ROM to remap the routines for the IEC port to use those different port assignments for the 6510 CPU. So all was well and good with this machine with the Commodore 64 CPU, but then a very nice viewer of mine sent in an actual 8501, which is the correct CPU for this machine, and that's what's installed. The thing is, I never changed the kernel back from the modified 6510 kernel, which actually says it right here on the sticker. So that means that the kernel routines for accessing the disk drive are incompatible with this original CPU. Now, in case you never saw my video where I modified this thing to support both PAL and NTSC, that's what this stuff is down here. There's an Arduino and a frequency generator, and this thing replaces the crystal oscillator on board to generate the two different clock frequencies required for PAL and NTSC, and then it also drives the EPROM to select either the NTSC or the PAL kernel, because that's the only difference between PAL and NTSC on these machines. It's the kernel ROM and the clock frequency. The actual graphics chip, which is the TED chip under this heatsink, is the same for both models. That is different than the 64. So to fix this computer, I need to pop out my modified kernel, and I will need to make a new EPROM that contains both the PAL and the NTSC version of the stock kernel for this machine. Okay, I put another chip in there where the two ROMs are swapped around, and it's working. And if I hold down the reset button until this flashes twice, there we go, let go, it's going to switch into PAL mode. You can tell the borders are bigger, the colors are slightly different. That's when it's in PAL. And if I hold this down, this will flash once, like that, let go. It resets the machine, but then it will reset it again as it changes the clock frequency and everything. Should go back to NTSC. There we go. So the real reason I wanted to get the IEC working again is it's not that going to affect the cartridge port disk drive. It's purely an IEC thing. I want to use my SDIEC because it turns out there's a diagnostic program for testing the disk drive. And by the way, I've modified my SDIEC so it has a USB connector on it because obviously I can't plug this into the cassette port on this machine. So I'll just plug it into my little USB adapter on the wall. There we go, that's powered up. Turn this on. Theoretically, I could type directory as well. Oh, look at that. It just works now. Sweet. Okay, I copied the test program onto the SD card. Let's see about this. Interface check. Oh, this is a Rob Clark production. The paddle and drive are very sensitive. All power must be off before you attempt to connect or disconnect the drive. 1551 should be connected but powered off before you start. Power down and start again if required. All right, I've connected this back up. Everything's turned off. I have the IEC on device 8. So I'm going to turn this on with this off. That way, hopefully we can load that program off of this. I think based on what we saw before, what I can do is run this and we can hit enter. And it said, okay, should be connected but powered off. That's what do we have here. Okay, so it's able to communicate to, I suppose, the CIA that's inside the paddle, which we knew was working because we're communicating with the drive. So that's a good first step. Checking registers can hold a 0 value. All right, okay, everything looks good. Now this is working with the drive powered off is because what's in the cartridge is powered up by the computer. So you should never connect the cartridge while the computer is turned on. That would be bad. But as far as I can tell, the drive itself does not power up the cartridge. So if the drive is on, but the computer is off, you can plug the cartridge in. Well, I think you can at least. So I think all these tests though are really testing out the paddle or cartridge. And I'm hoping at some point it's going to tell me to turn on the disk drive and then it's going to test communication to the disk drive. I mean, we know that's working, of course, too. We need to test the part of the disk drive that reads the values off the floppy disk. Is the drive configured for 8 or 9? It's configured for 8. Power on the drive now. Okay. There we go. Hit enter. Okay, that test work. Okay, checking internal drive pull-ups. It's my theory that this test is going to show everything is good. Because I really feel that, oh, Unstable. Oh, ignore bad unstable on port C. Okay, fine. Yeah, it's my theory that the drive is going to test or pass all of its tests without any issues. I think the issues in the drive lie beyond the 6523, whatever, the CIA chip that's in here. Spinning the disk. LED's on. Head bang. Read error. Bye. Okay, well, that's pretty much exactly what I thought was going to happen. Like I just said, it's going to pass all the tests, except it's not going to be able to read anything because we know the drive can't read anything. And it's not the bad heads, it's what we already talked about. So Bob's diagnostic routines didn't help us in this case, but that's okay. It still, I think, would help a lot of people if you're having communication issues like I was having before with potentially the PLA or whatever was going on initially. I think it was just a bad connection in the cartridge port, to be honest. So Mark over at the Retro channel, thank you very much for your help sending me that diagnostic. I think it's now time to start swapping some chips. I have the large gate array right here. I took this off of a 1541, another parts board. Let's try this one first. Okay, everything is turned off right now, and this is the extra gate array that I took off a 1541 parts drive. Remember how I said it was a 40-pin dip, not 42? Well, the one that's on here is 42, so I had to install a couple extra pins, but it doesn't look like those extra pins do anything. It seems like those extra pins are strictly like ground and 5 volts, an extra ground and 5 volt pin. So you might notice that down here on the edge, I have extra 2 pins installed. So when I put this chip in, which is only 40, I need to make sure I put it up towards the notch. Okay, there it is, it's popped in. I hope this doesn't cause any destruction in the drive. Okay, here we go. Oh, that didn't work. As soon as I powered on the drive, it didn't spin and the LED was on solid. So that's interesting. That tells us that this chip is not exactly the same. Okay, and I just assumed it was the same. Okay, let's put the original one back in. Let's make sure I didn't damage anything. No, seems to be fine. Turn on the computer. DI Shift R. No, it's doing the same thing. It's just trying to read it. It's going to fail. Okay, so this is the part I tried to install on the drive. 64H105U 325572-01. And the gate array in the 1541B is that part, which is a totally different part number compared to the one that I tried to use just now, which was this one. 325572-01 versus 251828-02. And I guess 64H156 versus 64H105. Okay, not compatible, my mistake. Unfortunately, this part that's in the drive is made by Hitachi and it doesn't have any normal MOS type part numbers. So I can't compare what's on here versus what's on the 1541B. All right, so because I don't really feel like desoldering a 40-pin IC right now, let's start with that smaller IC on this drive. Let's see if that one fixes the problem first. If it doesn't, then I'll go to this. And if it doesn't, we're gonna have to switch the hybrid IC and maybe that will fix it. All right, so to save you a bunch of chip swapping, I swapped in the large gate array and the small gate array together into this board from the 1541B, and it made no difference. These work in this drive. Well, I mean work as in it tried to read a disk and got a read error, but there was no improvement with these in there. So I put the originals back in, and I think it's now time to swap the hybrid IC. Okay, I've removed the hybrid. This is the 1551 board. And here are the two hybrid ICs. Now, the problem is I was gonna install some pin headers so I wouldn't have to resolder and switch these around or whatever, but the pin spacing is not standard, so I can't. This one has a little dot on it. This is the one I took out of the 1551. This is from the other drive. I guess I'm just gonna install this one onto there and, I don't know, hope for the best. The part number is almost the same. This one's just a -01 and the other one is a -02. What sucks is if this fixes the problem, that means I have a bad hybrid. And I mean, seriously, is it possible to get another one of these? Yeah, exactly. Incidentally, there were some bodge wires on this one. I took some photos ahead of time so I could reinstall them back in their original position. Right, the hybrid is in. I feel that it's the least likely situation that this is a bad part. At this point, if this doesn't fix it, it's not these 3 chips, then the only thing that I can think is the issue is the 6525. And you know what I didn't even do? I didn't even deoxit these sockets. Oh, what if it was that? What if it was that? You know, the funny thing is, as I was having dinner, I thought about that. I thought about deoxidating the sockets, but when I came back down, I immediately forgot that that was something that I might need to do. And if it is a bad connection to either of these two sockets, that will have been such a colossal waste of time. Just double checking that that is in correctly, and it is. Here we go. This might let the smoke out. I'm going to turn on the drive and let's hope that that thing survives. Here we go. 3, 2, 1. Okay. Nothing bad has happened yet. These do get warm, by the way, while they're operating. That is not warm, luckily. Not yet, at least. All right, here we go. No. No change. No change at all. No. Okay. Well, that's good because that's certainly not an easy part to get. So I'll put this one back into the other drive and just leave that in there. All right, well, I've turned off the computer and the disk drive. Let's pop out first this 6525. It's weird how the schematics say 6523. Let's get this out of here. Ooh, it's very crunchy. It's in there very well. But we will deoxit that socket. What if it's one of those terrible, cheap, unreliable sockets and I didn't even check it? And oh no, that's not a bad socket. That's actually a double wipe socket. It's not terrible. So we'll just give this a nice bath of deoxit. Double check. Pins all look good. Yep, nothing's broken. Nothing looks out of the ordinary. Okay, that's back in there. Let's make sure this chip is all the way in the socket, sort of partially popped out. Okay, let's see what happens. DI, Shift R. Okay, it's not working. Let's get the CPU out of here and we'll do the same thing. Now this has some IO lines on it. That's why they're using a 6510 versus the 6502. They're using or relying on some of those IO lines that this thing has. All looks good on the CPU. Yep, nothing out of the ordinary. CPU is back in. So this is the last potential fix because I think I've gone through everything on this drive and I just don't see an issue. So we'll turn this on. DI, Shift R. No fix. No fix. Okay, I power cycled everything. Let's try loading $sign. Oh boy, am I stuck. This sucks. This sucks. Well, at this point, I don't know what else to do. I feel like I might need another one of these drives to try the CIA chip, just do a swap on that one. That's kind of the last bespoke part that could be bad. I mean, I suppose the CPU itself could be bad, but it's just so strange this thing tries to read disks and is unable to. I'm pretty confident that we looked with the oscilloscope and saw the correct read signals coming through and all the other signals basically look correct on this drive. It just doesn't seem to be able to transfer any of the data that's read in from the disk into the CPU, which it needs to do for it to read anything. So as a final step here, which won't help me fix this drive, I'm just going to reassemble the 1541B. I want to make sure that all the work I did on that, including removing the hybrid here, hasn't broken that drive now. So this drive is the 1541B reassembled. Let's turn it on. Turn on the drive. Let's see if I can read the disk. Yes, I can. It just shows that this disk, which I've been trying to read, the alignment disk, does work. Let's try loading one of these into memory, even though it's not going to work. I just want to make sure that it is able to read data. It's going to do it very slowly. That worked. How many? Oh, that was only 3 blocks. Okay, look, it's a little program as well. Cool. Obviously, it's not going to work. It kind of tried to work. But anyways, it did read a program off a disk. That just shows that this disk drive with these parts, including the hybrid from the other drive, is working. I had one more thought. This was the extra mechanism from the parts 1541 that I had. What if this doesn't work? Because we tried this and the other one together in that other drive. Let me plug this into this drive, and let's just double check that this mechanism does indeed work properly. Let's put the floppy disk into this top mechanism, and let's hope that I didn't just have 2 bad mechanisms the whole time. No, it works. It reads just fine. All right, well, there it is, the 1551. I originally started this video thinking that it was going to be a problem in the paddle. Well, that didn't turn out to be the case because I guess we had a bad connection or whatever. So once the drive was up and running, which you saw at the beginning of the video, well, then I went down the troubleshooting path to try to figure out why I had read errors, and I can't figure it out. So hopefully someone watching this video has an idea of what's going on, but we've ruled out a bunch of parts. We know the drive mechanism is not the problem. We know the hybrid's not the problem, or the two gate arrays. Based on the result of the diagnostic utility, the paddle or the cartridge is communicating perfectly with the drive. All the registers seem to be working fine. All we're really left with is the 6525 and I suppose the 6510 CPU, the 6510T CPU as potential issues. According to the schematics, the entire path of the read circuit doesn't go through any passive components. It goes into the hybrid directly and then through the gate arrays into the logic circuits. So it's not like there's some kind of passive part that's bad on here, unless one of those baud wires on the bottom is causing an issue. But I don't have any other drives to compare to. So with those baud wires, not sure. There's a bunch of cut traces on the bottom. There's some on the top. Obviously, Commodore did a bunch of fixes to at least this board for this drive. But all these parts seem to work fine in this 1541. So it's not the parts that require it. It's obviously the PCB layout that is the problem. So I'm sorry this video has been unsatisfying. It's definitely unsatisfying for me, but hopefully, like I said, someone will be able to help me out in the comment section. If you did find this troubleshooting exercise where I completely go off the rails and can't fix the drive interesting, thumbs up would be appreciated. Huge thanks to my supporters. Names are going beside the screen, subscribe, YouTube stuff, etc., etc., etc. So I guess that's that. So stay healthy, stay safe. I'll see you next time. Bye.